Hi, I'm Gary Stafford, a Principal Solutions Architect here at AWS. Welcome to this demonstration of advanced video search powered by TwelveLabs and Amazon OpenSearch Serverless. I recently published a blog post entitled Multi-Vector Semantic Search, Advanced Video Search with TwelveLabs and Amazon OpenSearch. Today I'll introduce you to TwelveLabs video platform, its core AI models, its SaaS features, and then I'll show you how to combine these with Amazon OpenSearch for a scalable multi-vector semantic search solution. We'll walk through the Jupyter Notebook associated with the blog post, demonstrating all of the code. All of the code is open source and available on GitHub. The blog post starts out by introducing the topic, and we talk specifically around the nested field search. So as we get further into the demonstration today, I'll explain this a little further. But with nested field search, we're able to store a single document in Amazon OpenSearch with multiple dense vector embeddings, and that's going to be critical to having video understanding, and we'll explain that a little bit later. But nested field search is a key feature of OpenSearch which will enable our demonstration today. The blog post goes into discussing the main features of the TwelveLabs SaaS platform for multimodal visual intelligence. We talk a little bit about both of the models, both Marengo and Pegasus. I'll discuss those in a minute. And then we have a brief discussion of Amazon OpenSearch. So Amazon OpenSearch is the platform that it was used in the blog post. I also mentioned Pexels. Pexels is where I got all my videos for the demonstration. I'll introduce them also in a minute. And then we walk through creating an index on TwelveLabs, uploading videos, creating embeddings, doing search, doing analysis, all of the main features of TwelveLabs, which I'll also discuss in a minute. And then we get into the code part, and all of the code, again, is in a Jupyter Notebook. All of the code is available on GitHub, so there's a GitHub repository, and we have a Jupyter Notebook, which has all of the code that we're going to go through today. So you can clone this notebook and go through all the code in the demonstration. One thing that I will note with Amazon OpenSearch is a paid managed OpenSearch service. For today's demonstration, I'm going to be using OpenSearch locally in Docker. And the reason I'm doing that is to make this demonstration free. So if you're interested in going through this demonstration, you can download the free videos from Pexels. You can create a free TwelveLabs account, which gives you up to 600 minutes of video content and up to 50 API calls a day. And then you can download and use this code for free, and you can stand up OpenSearch with Docker on your local computer. So you'll be able to do this entire demonstration at no cost. So that's why we're switching from Amazon OpenSearch Serverless. Great solution for going into production, but just for demonstration purposes and for development and debugging, we're going to be using OpenSearch locally in Docker, and I'll talk a little bit more about that as we get a little further into the demonstration. Moving back to TwelveLabs for a minute, if you're not familiar with the TwelveLabs platform, just briefly discuss some of their main features. So TwelveLabs has two AI models, Pegasus and Marengo. Marengo, this is a multimodal embedding foundation model. Marengo processes video content across multiple modalities, visual, audio, and text, to generate specialized dense vector embeddings for each. This multi-vector approach allows for highly accurate semantic search and comprehensive video understanding. So if you're used to creating vector embeddings or dense vector embeddings for text or images, you're probably used to creating a single vector embedding for each one of those different assets. With TwelveLabs, we'll actually be creating multiple embeddings. If we have, let's say, a 3-minute video, that 3-minute video is divided into segments somewhere between 2 and 10 seconds. And then each one of those segments gets a embedding, which represents the visual content. And then if there's also an audio track, not every video has audio track, but if your video has audio, then there'll also be embedding for that segment for the audio. So for a 1-minute video, if we're using 6-second segments, we'll have a total of 10 embeddings, dense vector embeddings. And we'll be able to represent those in a single OpenSearch document and be able to search on those. And we'll go into more detail later. If this is all new to you, hopefully by the end of this demonstration, you'll understand this a little better. So that's the Marengo model for creating those dense vector embeddings, those multiple dense vector embeddings. And then we have Pegasus, which is TwelveLabs' second model. Pegasus is a video language model that takes these embeddings and uses user prompts to generate detailed textual outputs. With Pegasus, you can create summaries, chapter analysis, highlights, and even ask open-ended questions directly to your video content. The three main features, and let me just jump over to the playground here on the TwelveLabs platform. We see over here on the side in the playground, we have search, analyze, and embed. Search, analyze, and embed. These are the three main features of TwelveLabs platform. With search, you can search video content using natural language queries, reference images, so you can write a natural language query in text, or we can upload and use a reference image across our library of videos or our index of videos to use the correct nomenclature. This system understands context and intent, delivering precise video segments even when the exact keywords are not present. The next feature is Analyze. So using Pegasus, you can generate structured textual intelligence from videos, summaries, chapters, highlights, and more based on your prompts. And lastly, we have Embed, which we already discussed with the Marengo model. So you can use Embed to generate vector embeddings that capture the essence of your video and content across all modalities. These embeddings are crucial for downstream tasks like search and classification. Now to start, I've already created an index. We're going to get into this when we get into the code, but I wanted to show you the index visually while I'm on the TwelveLabs platform. I did create what is referred to as an index on TwelveLabs. We're also going to be creating an index in OpenSearch. But on the TwelveLabs platform, I have two indexes here. So the one that was included with the blog post was the Pexels video index. I have 30 videos in that from Pexels. I also have another index with commercials. Now the only difference here is the commercials have audio tracks where not all of the Pexel videos have audio tracks. And if you read the blog post, I created a visual only index. So there's no audio embeddings included with this. So just to keep it simple, we're just going to be creating embeddings of the video, the visual content of the videos, not the audio content. But you can also do audio, and using the commercials is a great example of that, being able to extract the audio from that. So this is the Pexels video index, which is similar to what was described in the blog post. Again, we have 30 videos. They're very short videos. They're typical stock videos. Most of them do not have audio. The total for those 30 videos is only 10 minutes and 14 seconds. They range anywhere from a few seconds up to maybe 2 minutes. The average is probably somewhere around 20 seconds. And we can get a different view though. So here's the keyframes from those videos. You can kind of get an idea for the content. We have the title here, and then you can see the duration of each video. And this is the main library that we're going to be working with today, or excuse me, the index that we're going to be working with today. So we have 30 videos from Pexels. Again, Pexels, if you're not familiar with Pexels, Pexels is an online platform that provides free videos, free stock videos, and photos for your personal and commercial use. So we're going to just be using those for personal use today. I just downloaded 30 of these. So I downloaded 30 of the SD size videos. I'll talk a little bit about some of the requirements for TwelveLabs in a moment, but I found 30 16:9 wide videos. Now there's different aspect ratios we can use. I'll talk about that in a minute. I downloaded 30 of these videos, and that's what we're going to be using to build our index. Those are the 30 videos from Pexels. Those are included in this index. You can build your own index. You can download your own videos from a number of different sources on the internet, or you can use your own videos. I happen to choose Pexels for this demonstration. And you can see here visual, so visual only, no audio component. And that's different if I go back to index. I mentioned I have this one with commercials that I downloaded from YouTube. And we see here that we have some popular commercials, but you can see here that these all have audio as well as visual. So if I were to download the embeddings, I would get an embedding for the audio as well as the visual component of the video. But that's not the case with Pexels. So again, just to keep it simple, we're going to be creating a visual only index. And again, this is the free account. So you can create a free account. You get up to 600 minutes with TwelveLabs. You can see even for all these demonstrations around the blog posts, I've only used about 144 minutes. So that 600 minutes will last you a while. And then the other thing I just wanted to point out that we discussed in the blog post is creating an API key. And you can do that right here. So you create your API keys here. You can have multiple keys. These are sensitive. You want to make sure you don't include these in your code and publish it anywhere or share these with anybody else. So this is how you create your API key. You're going to want a free account and an API key to get started with this demonstration. So those are kind of all the basics on TwelveLabs, on GitHub, on Pexels, on the blog post, and we're going to be jumping into the code next. Let me just go over to GitHub for a minute and just go through the README file. The README file has just a few instructions on getting started. So we have a diagram here that kind of demonstrates or visualizes what we're going to be doing. We're going to be taking a set of videos. We're going to pass those through the Marengo model on TwelveLabs. Those are going to be divided into those segments or those video clips I mentioned, 2 to 10 seconds. We're going to create a visual embedding for each one of those segments. And then this set of embeddings or this list of embeddings are going to be included in what's called a multi-vector nested OpenSearch document. We're also going to be using the Pegasus model, and we're going to be writing a number of natural language summaries or descriptions. We're going to have a summary of the video. We're going to have an analysis of the video. We're going to have chapter analysis. So these shorter videos, there's not really any chapters like there would be in a full-length movie, but we're going to do a chapter analysis. We're also going to look for highlights and describe those highlights if it finds any highlights. And then we're also going to do what is referred to as a GIF. So we'll get title, hashtags, those type of things. I'll go through that in detail as we move on. A number of different analysis. All of that information that's generated about that video, that natural language information, we're going to take that along with the embeddings, and we're going to put all that together into an OpenSearch document, and then we're going to index those into OpenSearch. Now I mentioned we're going to be using Docker instead of Amazon OpenSearch just to make sure we keep this demonstration free. If you want to follow along, you don't have to spend any money. But we're going to index all those into a video index, and we're going to be able to search on this index or this vector index using semantic search and some other techniques. The main file that we're going to be using today is the TwelveLabs Jupyter notebook. Basic requirements, you obviously need Python. If you are going to be using AWS, and the notebook allows you to use AWS, if you want to use AWS OpenSearch Serverless specifically, you'll need your AWS credentials. If you are going to be using Amazon OpenSearch Serverless, you'll need to have a collection. So you need to create a collection. If you're familiar with Amazon OpenSearch Serverless, you'll know what a collection is. Within the collection, we have indexes. Within those indexes, we have documents. So the blog post assumes that you already have an existing collection. Again, for Docker, we don't need to worry about that. This is only if you're using AWS, you'll need credentials in the collection. You will need a TwelveLabs API key. I showed you that briefly before. That's free account, create an API key, jot that down and keep that handy. These are the environment variables you're going to need. If you are in AWS, you'll need your region, typical credentials. There's a number of ways that you can use your credentials. The notebook uses those as environment variables, but there's a number of ways to do that. Obviously, there's a number of ways to do that are more secure. This is just for demonstration purposes. But if you are going to use your AWS OpenSearch Serverless, you'll need your basic credentials. You'll need your API keys I already mentioned. And then you'll need your OpenSearch endpoint. Now, locally, if we're going to run that in Docker, that's just going to be the local host, right? No HTTP, no HTTPS, just localhost. If you're using Amazon OpenSearch Serverless, you'll get your endpoint, remove the HTTPS:// and that will be your OpenSearch endpoint there. And we'll go through all this. This is all in the notebook, but just letting you know what you need in advance. Only thing you'll need to do before you get started with the notebook, obviously you'll need to clone the repository down and then jump into that directory. I have directions here for both Mac and Windows. I happen to be on Windows 11 today, but when I wrote the blog post and did all of this work, I was on Mac, so compatible with either. There are 3 directories you're going to want to create. There's one to hold our videos, or your videos in this case. There's one to output. I'll explain what is going to go in that folder, and then our final document. So we have our videos, what I'll call our intermediate files that we're going to be extracting from TwelveLabs. We'll build our documents, we'll put them in this folder, and that's where we're going to index from. Again, Mac and Windows, you'll want to create those directories within your TwelveLabs OpenSearch demo directory. Also strongly suggest that you create a Python virtual environment, no matter what you're doing. If you're working with Python, any type of project, you always want to create a virtual environment, although not required, highly recommended. Again, both Mac and Windows instructions there. I already have created my virtual environment. I'll walk through that. And then we can run the code, and that's going to be the notebook. Since we're using Amazon OpenSearch, we're using OpenSearch in Docker, not Amazon OpenSearch Serverless. There are instructions here. I'm going to assume that you know how to use Docker, that you already have Docker installed, Docker Compose. You know how to use Docker Swarm. I have all the commands here for both Mac and Windows. So what I've done is I have Docker installed. I've installed both images. Now, if you don't have the images, they'll get pulled down when you run the commands. I've pre-installed those. I have the latest versions. From the OpenSearch official project, I have OpenSearch and I have OpenSearch dashboards. I'll show you the dashboards in a moment. So you'll need those 2 images. And again, if you don't have them, if you have Docker installed, they'll get pulled down when you run these commands. I've just pulled them down in advance, so I have them on my local dashboard. And then when you run the commands, you should instantiate 2 containers. So a container for OpenSearch and one for OpenSearch dashboards. You can see those are running here. So I've created my Docker Swarm. I've done the Docker Swarm init. These are just convenience commands, right? It just grabs your ID, running a command to get your Swarm ID, and then it injects that into the Docker stack deploying. This will display a Docker Compose YAML file for Swarm, and that's right here. So if we take a look at that, that's also in the project. Creates 2 containers, OpenSearch container, again from the OpenSearch image, and then OpenSearch dashboards. And we're not going to be using these heavily. I'll show you the dashboards really quickly. Obviously, we need OpenSearch running. We're not going to make heavy use of the dashboard, but if you're having any trouble, want to check anything out, maybe want to write some queries, that's much easier to do, I think, in dashboards in the dev tools. And then you take those queries and put those into your code. You can see here there is a username and a password, so we'll be using this to log in. You can change that, recommend you changes. And again, this setup is not meant for production. It's just meant for local demonstration, development, and debugging. You can see the dashboards are going to be running on 5601, and OpenSearch is going to be running on 9200. So we'll need 9200 and need to remember 5601. But this will just create this Docker Swarm with 2 containers, and this is how we're going to be running OpenSearch for our demonstration today. All right, so I think we're ready to get started with the code. So I'm going to switch over to VS Code. So here is the project in VS Code. So I've pulled it down, I've cloned it. You can see here, let me actually just source use the README file. And I'm on Windows. I already have Docker Swarm running. Let me just activate this environment. Make sure I have my environment activated. Yep, so you can see here, I now have my virtual environment. So I'm in my Python virtual environment, which just means when I install anything, it's in that virtual environment. When I hold on, I just delete that virtual environment, and I haven't cluttered up my local machine or have any compatibility issues with my local development environment. So again, have my virtual environment running. I can jump into the notebook. So here we are in the notebook. Again, the notebook just kind of explains some of those prerequisites. I would go to the GitHub site. The README file is much more comprehensive than the notebook. There are some instructions. Now, I mentioned I use Pexels. There are video requirements for TwelveLabs. You can't just upload any video. So there is a minimum and a maximum size. Again, I put some of these requirements in here, but I would definitely check their API documents. TwelveLabs has great documentation and examples for all of their methods and functions within their API and SDK. They also have all the requirements for audio, video, text, etc. So for video resolution, there is a min and a max. So I stay pretty close to the minimum. Again, if you use Pexels, use the SD size, and there is a 360 pixel dimension size. So I use those. Made sure I was just above the minimum. So they're small videos, they go pretty quick. Aspect ratios, again, I use 16:9, but there are multiple aspect ratios available. So again, I would suggest the SD size, roughly 640 by 360 at 16:9. Those are the videos I use. You can use any videos you want, but that's what I use, and I have about 30 videos that I use for this demonstration. Started with 10, got it running. I think the blog post I used about 25. Added a few more just to get a little bit better search results. If your index is too small, if you have too few videos, you're going to get kind of wonky results, right? If I search for sporting events and I only have 10 videos and I only have 2 sporting events, the third video is probably not going to represent sporting events too well. Whereas if you have, a large number of sporting events, you have a bigger index. When I search for sporting events and I ask for, let's say, the top 5, I'm going to get 5 back that represent sporting events versus 3 representing sporting events. And then the 2 other closest to my match, we'll talk about nearest neighbor in a minute, or approximate nearest neighbor, but I'll get the closest to my search, but they may not represent the search because I just don't have enough content with that topic. So you want enough videos where you can search. So you also want some videos that are similar, right? If you're going to demonstrate this or test this out, let's say, again, you're going to use sporting events, make sure you have several sporting events. Just don't have one sporting event because the results are going to be a little odd. Obviously, in production, you're going to have much larger. If you're a stock photo agency, if you're stock videos, if your corporation has a large number of video contents, maybe you're a broadcaster, you're going to have thousands or more likely hundreds of thousands or millions or hundreds of millions of pieces of video content, and your searches are going to be much more robust. So the results are just probably not optimal, good enough for demonstration. Again, we talked a little bit about how this all works. The first thing we're going to want to do is install all of the packages. So I'm just going to update pip. I'm going to install the key package here is the TwelveLabs Python package. Boto 3 is for AWS. You can go ahead and install it. It's not going to hurt anything. We're not going to use Amazon OpenSearch serverless today, so we don't really need that, but go ahead and install it. And then the main package we're going to be using in addition to TwelveLabs for the second half of this demonstration is the OpenSearch Python library, which will give us access into OpenSearch. And we'll install the latest. So I have the upgrade and quiet, so you shouldn't get a lot of output here. We should get the latest ones. And then also later on, we're going to visualize some of the response that we have. So first part, we'll just do a search and we'll get a list of video IDs, but then we're going to want to try and visualize that. So a few packages help us visualize that. Now, the next thing you want to do if this is the first time you've done it is restart your kernel. So you can restart your kernel depending on what platform you're on. There's commands you can run, or I just did a restart here. And that will restart the kernel, make sure we have everything installed. The next cell, just to understand the TwelveLabs package a little better, we get a little more information on the TwelveLabs Python package, but it also kind of just shows us that it is installed. So we pip installed everything, we restarted our kernel, and then we're just doing a pip show, and we do see that we have the latest 0.4.10 package at the time of this video. So I have that loaded, so I'm ready to go. And then the last step here before we jump into our credentials is just loading the packages we need. Now, these aren't all the imports we need to do, but just to get started, we're going to import JSON and OS, and then you can see here the different TwelveLabs packages that we're importing. Next thing we want to do is our credentials. Now, again, I mentioned I'm not using AWS. These are all the credentials. I'm putting these environment variables just to kind of demonstrate how you might think about protecting your credentials. I'm just exposing those here, and you can say, hey Gary, I see your TwelveLabs API key. Yes, you do. By the time this video is done, I will delete this key and remove this key, so it will not be active. I didn't want to start hiding stuff and confusing the demonstration. So you put your TwelveLab key here. Again, if you're just doing this locally, you don't have your Amazon OpenSearch serverless endpoint, you just have localhost for Docker. So these are the only 2 you need. You can leave these blank. If you are using AWS, obviously go fill these out. And there are better ways to do this. There's other methods to load your credentials into a notebook. I'm just doing the most basic example here to keep it simple for the demonstration. I ran this cell. And you can see here now that I have set my environment variable for my TwelveLabs API key and for my OpenSearch endpoint. And I would consider all these sensitive. Now, obviously with Docker, localhost is not sensitive, but if this were on Amazon, I would consider all of these. Obviously your credentials are very sensitive. TwelveLabs API key is sensitive, but even your endpoint, you don't want to expose that potentially if you don't have it totally secure or locked down. So just security through obscurity, I would consider all of these potentially sensitive variables. The next thing we want to do, so we're just going to load those now that we have those in our environment. So I load my TwelveLabs key. Now I have that and I can use it. I also have my index name, Pexels Video Index. I'm going to keep the same index name for TwelveLabs. So we're going to create a TwelveLabs index on their SaaS platform. We're also going to create an OpenSearch index locally. I'm going to use the same name just for simplicity. And then you remember those 3 directories that you created before you got started? Don't forget to create those directories in your main project folder here before you get started that I explained in the README. And then we have those here, right? So we have our video directory, our output directory, and our documents directory. And we can see those. I have those defined right here. And you can change those if you want. If you're not using Pexels, feel free to change those, do whatever you want with those. The next thing we're going to want to do is create the TwelveLab index. And the first thing we always do is create what is called a TwelveLabs client. So using my API key, I've now instantiated a TwelveLabs client that I'm going to be using for all my commands. We'll go ahead and create the index. Now you can say that the index already exists. So we talked a little earlier about the fact that I've already created a TwelveLabs index. If you remember in the playground, I showed you the 2 indexes and I have the Pexels video index. Just to save time, I've already created the index. Creating the index takes not even a second. It's almost instantaneous if you do run that command. So not a problem. I've just created it in advance. One thing I want to point out here, visual only for the models. So for the models, for the options for the models, if you did have audio, you would simply expand this and also have audio here. So if you had videos that had audio, an audio track, you would just add audio there. I'm using visual only since I only want visuals, and almost all of the Pexel sample videos that I'm using don't have audio anyhow. So, but that's how you would add audio, is just add it to both of these. And then you would have an index that has both visual and audio. And you remember I showed you that at the top of those indexes when we were in TwelveLabs. You do want to run this command though, even if you already have the index, because we're gonna set our TwelveLabs index ID, and that's the index ID that we're going to use for some of the additional commands. So you can see that the name of the index is Pexels Video Index, but it has a unique ID, and that's what we're going to go by for a lot of our commands. To keep going now, we can upload the videos. Again, I've already uploaded the videos, and this is what will take a few minutes, and that's why I did this in advance. So again, I showed you the index, I showed you the 30 videos. I have all the videos here, so if we look under videos, tip that down, and you can see Pexels, I have all my videos. I've already uploaded all these, so I ran this command in advance. Uploading the videos are very small. If you have good bandwidth, should only take a few seconds. What is going to take a few minutes potentially is to index those, right? So all of that rich visual information, that audio information potentially, all that needs to be indexed on TwelveLabs. And you know, that might take 30 seconds to a minute of video at most. A few minutes for 30, they're pretty small videos, but that does just take a few minutes. So I ran this command in advance. If you just created your index, go ahead and run the upload videos command. It'll look for your video directory. It'll take all those videos. It'll upload them. You'll also get if any of these are not the right size, if they're too small, if they're too big, if they're not the right aspect ratio, if they're not the right file type, it'll throw some errors, and you'll want to check on those. But as long as you stick to MP4s, again, within the right size, I'd keep them small, 640 by 360 in my case, 16 by 9 aspect ratio. They're pretty small videos. I didn't have any trouble. A few were too small, so I just replaced those with ones that were just a little bigger that fit within the minimum. The next thing that we're going to want to do is retrieve the embeddings. So I mentioned dense vector embeddings. If you're not familiar with embeddings, I'm probably not going to go into a lot of detail here. I'll show you a quick embedding. So this is an embedding. This is a dense vector embedding that was created from TwelveLabs, and it has 1,024 dimensions, which means there's 1,024 floats within this dense vector embedding. And that number can vary depending on the model that you use. In some models have variable dimensions. So this has 1,024. That means that for every video segment, we're going to have a visual dense vector embedding. If we have audio, we'll also have a audio dense vector embedding. So for each one of those, we'll have a dense vector embedding with 1,024 floats, and that describes that video, right? So we've converted the information or the analysis of that video, the details of that video or the audio track into numbers, into a dense vector embedding of 1,024 dimensions. We've uploaded all those videos into an index. Now for embedding specifically, I don't need an index. And I won't go into too much detail, but if you're using the TwelveLabs API, I can simply upload a video and get my embeddings back. I don't need to index it. I did index this because in order to get the descriptions using the Pegasus model, Today, there's no way to do that directly. I do need to put the videos in an index in order to create some of those natural language descriptions or summaries or highlights. So I went ahead and I'm going to pull the embeddings from the index. So the first thing I'm going to do, because potentially I could have millions of videos, I want to be very explicit in which videos I want. Now I'm just using a query search here of star. I'm going to get all the videos back, but we have this method, get video IDs, and you can change this search. This just gives me a list of video IDs, and I'm going to iterate through those in order to get my bulk embeddings. And I'm also going to use the same list of later on to create my descriptions. So if we go ahead and run this, you can see it's running, and what it's doing is it's for the 30 videos, it's extracting the embeddings and it's going to write that to JSON. Now you could just store that in memory, you can get the analysis, you could write all that directly to OpenSearch. I'm being a little more methodical. I'm pulling the embeddings, writing those to JSON, creating the analysis, writing those to JSON, combining those two JSON files into a document, writing that to JSON, and then uploading that JSON document to OpenSearch, just to be a little more pragmatic here. But we could certainly use a database. We don't have to write to, it's a lot of file IO, especially if we have a very large index. But for the small demonstration, and it's also easier just to kind of show you what's going on. So I ran through those 30 videos. Now you can see it's skipping. I already ran this in advance just to make sure everything was working. And we can see here in the output, if I go to Pexels, you can see here there's actually 60 files. So there's 2 steps. This was step 1 of 2. Step 1 creates an embeddings file for each video, and I use the video ID, the unique video ID. And you can see here that we have embeddings. So if I tip these down, we can see that we have some basic information. We have the video ID, when it was created, file name, the original file name, the duration, the frames per second, the width, the height, the size of the video. So that might all be useful for your search. So good to have that. We're going to include all of that in OpenSearch. We also have some things that are kind of unique to TwelveLabs. There is a URL that gets you back to the original video. And then there's a thumbnail. And we're going to use a thumbnail later to visualize the search results. So this thumbnail will be useful later on for us. And then the main thing, the most important thing here is our embeddings. So you can see here, within this object, we have an embeddings object. Within this embedding object is the video embeddings object, so deeply nested here. And then within that is a list of segments. So the video, in this case, the video was 14 seconds long. It took the video, TwelveLabs took the video, broke that down into clips or segments. And you can see here, if I tip this up, there's 2 segments. So segment 1 starts at 0 and goes to 7 seconds. And this is the visual, right? If we had audio, we'd actually have 4 segments, 2 visual and 2 audio. In this case, we only have 2 because it's broken that video, looks like into half, so 0 to 7. And then if we look at the other segment, it's going to be 7 to 14, so 14-second duration. We have 2 7-second segments. And for each one of those, we have this dense vector embedding. So within embeddings, we have video embeddings. Within that, we have segments. Within that list of segments, we have each segment. And then within there, we have the embedding float, which is our dense vector embedding. Again, you can see it's a clip, 7 seconds to 14 seconds. In this case, that clip, that piece, that segment of the video, and this is the visual. And again, if we had audio, we'd see audio in here. So we've extracted that, and we've extracted all this information into temporary JSON files that we're going to be using to upload to OpenSearch in a moment. Next thing we want to do is create those analysis. Now I mentioned again that we only have 50 API calls a day. We have 30 videos, and we just made some calls to get those in dense vector embeddings. We also are going to want to create summaries. I'll go through these in a minute, but we're going to make multiple calls within this method. And obviously with 50 is not going to be enough. So I've already ran this in advance, and that's why you see 60 files here. So in addition to these embeddings files, you see the analysis file. That's critical. We have the analysis. That's what this is going to do. So this method, we run this method. There's a number of different options we have, and we also have freeform. So you can ask anything of the video and get a response back. But there are some boilerplate standard options also. So as we go through here, there is what's referred to as summarize. So the summarize method has summary, chapter, and highlights. You can see here we're calling summarize 3 times, and the difference is the type. You can also change the temperature, and I would read up a little more on how this affects the output. I'm just using a relatively neutral 0.4, and then I have a very basic prompt, right? Summarize the video in a concise manner, list the chapters of the video, list the highlights of the video. So those are 3 analysis. Each one of those is going to give us a separate result. We're going to put all that into OpenSearch so we can search on it later on. We also have what's called an open-ended text analysis. And I'm doing something very basic here, super basic, describe what's happening in the video. This could be a much deeper analysis, right? Analyze this soccer game. What color are the jerseys? How many players are on the field? Analyze this video. How many people pass this spot? I'm just making this up. But again, you can do deep analysis using the TwelveLabs models and the embeddings in order to analyze a video. Again, very basic here, but you get the idea. So in addition to summarize, we have analyze, and lastly have what's referred to as the GIST. And the GIST has 3 different options, and we're going to use all 3 options. With the GIST, we can extract or have 12Labs generate a title, a list of topics, and a list of hashtags. And I'll show you what those look like in a minute. We're going to make all these calls. We're going to get a lot of rich information. We're going to get our GIST with our title, topic, and hashtags. We're going to get our summary. So 3 different types of summary, the chapters, and the highlights, and then our open-ended analysis. We're going to take all that, we're going to write all that to JSON and write that to DIS2, and then we're going to put all that into OpenSearch. And you can see one of those here. So here's our analysis. Let me just make that look nice. And you can see here's our GIST, right? We have a title: mountain bike adventure through the forest leads to unexpected gathering. We have the topics, we have some hashtags, and then we have our summary that we created, we have our analysis, and then we have chapters. Now these are very short videos. If this were a long form video, if this were a movie, let's say, obviously we're going to have multiple chapters and we're going to have a lot more highlights. These are very short stock videos, no audio. We're not going to get a lot of chapters. Most of these are just going to have 1 or 2 chapters and maybe 1 or 2 highlights. So this is kind of the minimum example of what was extracted. But again, if this were a full-length video, you'd have multiple chapters, multiple chapter summaries, you'd have multiple highlights summaries. So again, this is kind of the most basic form that analysis will take, but for a longer form video, this would be much richer. So you can just see here that it's going to be skipping through. If I was missing any, there's 30. It looks through the directory and it takes a look at the directory, and if it already exists, it skips that just so we're not making a lot of additional API calls and overwriting files. And you can change it if you want. Maybe you want to reindex or backfill your index. You can change that logic, but I'm just going to skip over it since I already have those. The next thing we want to do is merge the embeddings, the list of embeddings, with all of that analysis that we just did. So we have our embeddings and analysis files, and we want to combine those into what's referred to as an OpenSearch document. And you can see I have those here. So we can run this command and combine those segments. And again, now I've already run it just to make sure it works, but you can see here document already exists. So again, it looks at the directory. It's not going to recreate this. It's not going to do a lot of extra work if it doesn't have to. Again, if you want to do backfills and you want to recreate these, just change some of the logic. Easy enough to change the methods, but I'm just going to ignore that since I've already created. These are our final documents. So again, here's our GIST, here's our video ID, our index ID, summary, analysis, chapter, highlights. We can see all that if we scroll down a little bit, and then we get into the embedding. So I've taken all this. I removed a few fields just for demonstration purposes that we really didn't need, and there's other fields here we really don't need that are probably not important depending on your use case. And put all those into here. Obviously, any fields you remove, you're going to save a little bit of space. But really, the bulk of these documents, the real size is in these dense vector embeddings. So if you have a lot of embeddings, that's going to kind of balloon the size of that document. Not too big for OpenSearch, but if you get into longer form videos, you need to start thinking about how you're going to store these. Do I want to store this as a single document? Do I want to store this as chapters? There's a lot of different logic you could apply, but for these short videos, everything is going to be in a single document, whether it has 1 embedding or 10 embeddings. I'm storing all that together. So again, we've put all of the information together, and these are our documents that we're going to be uploading to OpenSearch. We're kind of done with TwelveLabs. We're going to call TwelveLabs just once more to create an embedding for search, but for the most part, we're kind of done with the TwelveLabs side. Now we're going to switch to Amazon OpenSearch Serverless. And again, Amazon OpenSearch Serverless, remember, we're using Docker locally. So I mentioned we're using Docker. We have our 2 containers stood up in our Docker swarm. For all of the work that I'm going to be doing, all that's going to happen locally instead of on Amazon, just to save money and cost and make this free for folks. So we can go ahead and walk through these cells. Now, most of these cells are oriented, the first cell and then the second cell specifically, most of this is around AWS, but you can go ahead and run them. It's not gonna fail. We haven't actually called AWS yet. The third one here is the Amazon OpenSearch client. I'm going to skip this cell. We're not going to run this cell because we're not using Amazon OpenSearch. If I run it, nothing's going to necessarily fail. It's not instantiating anything yet. You could go ahead and run it even without the credentials. It's not going to fail, but you don't have to run it. Really, what we want to do is run this next cell, which is recommended for local development. Again, this is an alternative to Amazon OpenSearch Serverless. We're going to OpenSearch in Docker. So you can go ahead and run this, and this is going to instantiate our OpenSearch client. And that's based on, again, remember we set our variable to localhost. Remember I mentioned port 9200. And then I mentioned the username and password, so very basic auth, HTTP auth. Those were set in that Docker Compose file, so we have that in here. So this is going to create our client. It's going to authenticate. It'll hit localhost on 9200 where OpenSearch is running. And then I'm just suppressing some warnings because this is fairly insecure just for local development. Every time we do a search, it throws a warning. So I'm just suppressing those warnings for convenience so I don't have to see them. So the next thing we want to do, now I've already tested this, I already have an index. If you have a large index with thousands, hundreds of thousands, millions, you don't want to keep deleting and rebuilding the index. for this demonstration purposes, I've added this feature. So we're going to go ahead and delete the existing index. So now that index has been deleted. So I deleted that pixels index. You can see I had it here. So now I don't have any index, just like you if you were just starting this demonstration. And we can create a brand new index. So this create index is going to create an index. I'm not going to go into all of these settings. The blog post goes into detail on what all of these settings are used for. Things like number of shards, some of the mapping, the different engines that we're using, the type of engine, the vector space that we're using. It goes into details. Pretty basic though. These are all the settings right here primarily that we need to do to build our index. The key feature here and what makes this a vector index and capable of doing semantic search using vectors, using k nearest neighbor, we'll talk about that in a minute, or approximate nearest neighbor, is that we set k and n to true. So this is the one of the key things that we need to do is set this to true. And this will make this OpenSearch index a vector search index. And that's going to be key. You can also see down here another thing that's key. Since we're using TwelveLabs Marengo model, Marengo generates dense vector embeddings with 1,024 dimensions. So there's that number. We want to make sure that we have the dimensions right. The last thing I'll just show you here, remember I talked about nested embeddings, so the ability to store multiple embeddings. And if you remember when we looked at the structure of the embeddings file, let me just open one of these documents again. We can see here that if we just scroll down here, we have this object hierarchy, right? So we have segments, then within segments, we have segment embeddings. So within segments, we have a list of objects which represent each segment of the video, audio or visual. And then within that, we have the segment embedding, which is our embedding. When we set this index up, we need to make sure we get the structure right. So we have segments here, and then you can see right here in properties, we have segments embedding. So segments came from our document structure and segments embedding came from the document structure, and that gives us that nested capability. And then within this, within segments, we have multiple objects with multiple embeddings under that segment embedding, and this describes that and how we want to search on that. So we'll go ahead and run this, created pretty quickly there. So now we have our index. It's an empty index. We can get some information about it, so we can run this next cell. And if you just kind of take a look at this, this basically matches what we just created. So we can see here that similar structure. Just kind of look through here, everything looks right. The other good thing is just running this information, the cell getting some information, that means the index was created. That also means our client is working, we're able to connect to that index. So this also just demonstrates that everything's working well. So good cell just to run and make sure everything is working. So I mentioned now we have an empty OpenSearch index, OpenSearch running in Docker. We've created an index. That index is empty. So next thing we want to do is upload these documents. So we created these documents, these 30 documents. We want to load and index those documents. So let's run the next cell. And we can see here a total of 30 rows. That sounds right. Now I'm going to run this cell, and you can see immediately it says indexing completed. If you're doing this locally, you create an index, you index those documents, it's going to happen almost instantaneously. With Amazon OpenSearch serverless, there is about 60 seconds between the time you index the files and you can actually start searching, and those files will show up. So if you index all those files and immediately run a search, it's going to say there's no documents available. You're going to get errors. You're not going to get any results. That's because Amazon OpenSearch serverless has this approximately 60-second delay. Again, that might vary depending on the number of documents that you index. But for Amazon OpenSearch serverless, if you run this, it does polling every 10 seconds. And it will keep searching, and what it'll do is it looks at this count of the bulk upload or bulk indexing that we just did of all these documents. It will keep refreshing every 10 seconds, and it'll keep updating the count until the count equals the count that you bulk indexed. So just a convenient method. Again, that's probably only going to run for, if you were to do this on Amazon OpenSearch serverless with 30 videos, not going to take more than probably a minute. We're ready to go. So I have an index. I have 30 videos represented in 30 documents, multiple embeddings, ready to start doing some searches. So a couple different options here. So what do we want to search? And I mentioned you have a couple different options. I have two options in the notebook. One is using a text query, show me all the sporting events, or in this case, we have busy city scene with people walking and cars driving. So that's what I want to search on. I want to see all the videos, or somewhere in the video shows a busy city street scene with people walking and cars driving. I can also use an image. I could use an image, and there is a sample image. Let me just close this up. And if we look down here, there is a sample image. Busy street scene, typical day, a lot of pedestrians, cars driving, some visual clues. Maybe I love New York, so a few visual clues that this is New York City. You can use a text-based query, or you can use an image, and there is an image included in here. And that's what these cells do. Now, I mentioned we're not done with TwelveLabs. There was an announcement that TwelveLabs is going to be on Amazon. So if you're running on AWS, there was a public announcement that TwelveLabs models are going to be on Bedrock. That has not happened yet. So today, in order to create the embeddings, get the analysis, and then when I'm ready to actually do a query, I need to convert that query into an embedding. I'm going to be calling out to TwelveLabs. Now, once those models are on AWS, if you happen to be on AWS, you could call Amazon Bedrock, but if you're not on AWS, you want to do this locally, you can just continue to call TwelveLabs. So that's what I'm doing here. I have this query, which is a text query, busy city scene with people walking, cars driving. I'm going to convert that to an embedding, because in order to do a semantic search, I need to search using an embedding. So I'm searching a set of embeddings. Each one of those embeddings represents a segment of a video. And the way I do that is turn my search criteria into an embedding. So I'm converting this query, this text, this string, into an embedding. You can see here just a sample of that embedding. And then I could also do the same if I were going to search with the image. And again, it doesn't matter if it's text, image, or audio, it's going to create it to the same 1024 dimension dense vector embedding. And that's when I'm going to use the search. So it doesn't matter if it's text or it's an image, it's going to end up as a dense vector embedding. And I'm going to use that to do a semantic search, which looks for the nearest neighbors or the closest match to this vector embedding using semantic search. We could keep calling this. Again, since you only have 50 API calls a day, what I've done is I've actually saved these embeddings locally. And if you're doing a lot of testing, you're trying to debug something, sometimes it's helpful just load these embeddings from disk. So I've saved these here. You can see both of those files are here. And again, if you want, obviously, if you change the image or change the description, you'll need to do that again. But just for convenience, I wrote those locally. And then as I'm doing testing, I can just load those. I don't need to keep calling TwelveLabs APIs to get those embeddings for testing purpose. Again, optional. Obviously, if you're maybe in the future using Bedrock, there is a cost to that. So this will just save costs for debugging. So let's get in. Here's our actual search. So now we're ready to search on OpenSearch. We're going to do, again, what's referred to as semantic search. I'm not going to go into a lot of detail. There is a link here that describes each one of these search mechanisms. If you're not familiar with semantic search, if you're not familiar with dense vector embeddings and how vector embeddings or embeddings are used to do search, whether that's K nearest neighbor or approximate K nearest neighbor, I would read up here. I'm not going to go into a lot of detail. This is more just a code review. So you can see here we start with a basic semantic search or an approximate KNN search. We have our query. We're going to return 9 records. So we're going to get the closest 9 segments. The closest 9 videos, not segments, the closest 9 videos. We're going to use the segments and score those segments, but then we're going to return unique videos, not segments. The other thing I want to call out, right? Typically, if I'm doing a search, I want to find what video, maybe I need the video ID or the URL. The one thing I don't need, and it's the biggest part of these documents, are the segments themselves, the embeddings. So I'm going to exclude those. There's no reason to return those embeddings unless you want to visualize those embeddings. And there is a use case later where I will return the embeddings, but for these first couple searches, we won't return the embeddings. So again, you can see I have a list here. You remember my query, busy street scene, pedestrians, cars. Here's my results. So I have the first one. Now this video ID doesn't mean much, but just judging by the title here, street level footage captures flow of daily commuters and traffic, bustling city square, a day in the life of pedestrians, Hong Kong at dusk, exploring London's busy streets, busy intersection, right? These all, without looking at all of these, looks like the search worked. And there's also a score. So the highest score was 0.69, followed by 0.67, another 0.67, 0.66. They're relatively close. There's not a lot of spread here. I don't know if that's the TwelveLabs model specifically. They are very close, but it really doesn't matter. These are listed in order, and what this is saying is here are the results. Again, if I have a very small index and a very large number of results that I show, at some point I'm not going to have street scenes anymore, right? If I put 20 in here, at some point I'm going to have I think there's a video of a camel walking in the desert. It's going to show up at some point because I've asked for a larger data set than is possible with this small index based on the description of what I'm looking for. But this works pretty good. So I obviously have enough videos here that I purposely put in this index that show a city so that search results look relatively good. And that also makes the scoring relatively similar. So that was a semantic search. You can also add a filter. So again, I got that search result. We're going to run the same search result. We're going to use that same embedding, right, that we created, that text embedding. We're going to return 9 records. The only difference here is you can use filters. Now, this is a very basic example. I only want videos where the duration is greater than 20 seconds and less than 60 seconds, or greater or equal than 20 seconds. So every video that gets returned, I only want videos between 20 and 60 seconds. So that did change this a little bit. If you remember, our top result was like low-level scene of people walking. I don't have that anymore. That's because that video was under 20 seconds. So now what was the number 2 result is now the number 1 result. The number 1 result was not long enough to fit that filter criteria. So we can do KNN, K nearest neighbor, approximate nearest neighbor, semantic search. We can also apply filters to that. using any of the other fields that were in our document. And so system metadata, duration was one of those. You could use any of those other fields also, and you can have multiple filters. So we've combined our semantic search with some filters based on those other document fields. Moving on, semantic search with inner hits. These results are good. These are the videos that match. But remember that these videos, and let's take this 28-second one, that probably has multiple segments. Well, specifically, what segment best represented my search? I don't know. I know this video represented it, but maybe what I was searching for happened in the, let's just say this was a 30-minute video. Maybe that particular scene, which was a close match to my search criteria, was 10 minutes in or 20 minutes in. How do I know which segment scored the highest within that video? So I got rid of my filter. I took the filter off, but I do have this inner hits here. So you can see here inner hits. What I want to do is identify the embedding within that nested embeddings, which embedding scored the highest, that had that score that we saw in the searches. And then I'm just going to return some fields from that. So within that, there's the start and the end offset. So I know which segment was returned. So let's just run that. And now we see here a little more information. So, and again, this is just, I'm formatting this. You could return this any way you want and make it look any way you want. You remember our score in our original search was 0.69. And this is a 15-second video. So odds are actually we did take a look at this one. So we know there's two segments. There's two roughly 7 to 8 second segments. We can see here that it was actually the first segment in a zero-based scale. 0 to 7 seconds is where that score came from. So 0.691554, same scores here. That score was actually derived from the first segment, or segment 0. And if we look down here, we can see that changes, right? So for the one that came in third, the third highest score, that was actually the second segment, again in a zero-based scale, segment number 1. And that was a segment that started at 5.5 seconds and continued to 11.1 seconds. So for my search within this 11-second video, it was actually the second segment, with probably of 2 segments, the second half of this video best demonstrated that. Now, one thing this isn't doing, and this might be obvious, imagine a movie and I did a search and that search was very specific to a particular movie. I would still get 9 movies back in this case if I were to use 9. I wouldn't get 9 segments back of the same movie. If that's what you want, there's other ways to set this up. The way that I'm doing searches, I'm getting back a unique list of videos in this case, different videos, versus these are the highest scoring segments. And if, let's say out of 9, 5 of the highest scoring segments were within one video, I would get that same video back with each one of those segments, and that would represent 5 out of the 9 search results. That's not happening. So I am getting back 9 unique videos, and this is showing which segment scored the highest. Odds are that within, let's say this video, there's at least 2 segments. Maybe both of those segments scored higher than the second place one. It doesn't matter. I'm only getting the segment that scored the highest, because what I've asked for is a unique list of videos. I don't want to return segments within a video. Now, if you want to return, let's say, clips within a video that show something specific, let's say in a movie, maybe there's a car in the movie that appears 4 or 5 times, and you want to know all the segments in the movie in which that car appears, different type of search. That's not what we're demonstrating here. This is about getting a unique list of movies versus a unique list of segments within movies that best represent your search criteria. Hopefully that makes sense. The last thing I'm going to do here, and this is just an expansion on that, is you can see now that I list all the segments. So again, it doesn't change the fact that I got 9 videos back, 9 unique videos back, but what it does show is what the clips are within those videos. So this 0.69 again, we can see here again, it was clip 0 if you remember from the last search, but I can also see segment 1, which is 0.68. Now, interestingly, this demonstrates what I was pointing out. Both segments within this video are higher than the second place, the second highest scoring video. But in this search, I'm getting a unique list of videos, not a unique list of segments. Because there was a segment that scored the highest, it returned this video, and then it moved on and looked for the next highest scoring video, which happened to be this. And of the 3 segments within that video, segment 0 was the one that had the highest score, that matched my search results the best, that was the nearest neighbor to my search result vector. Hopefully that makes that a little clearer. But this is useful if you want to see what the scores are. you could return this, and now you could jump in and actually view these segments, and maybe you ignore this or you ignore some of these later results, and this becomes your search results. So between the first two videos, you look at those scores and you maybe say, well, actually this 5 segments here are really what I want, and then you use those. So different ways to use this. Again, we're just getting a unique list of videos versus segments. There are many other search options. Radial search, for example, the square Euclidean distance versus the k nearest neighbors have a squared Euclidean distance here of 2, and we get back similar search results. These search results will probably look almost identical to their search results because I have a very small index of videos. If this were larger, again, there's many ways to use OpenSearch to search, and I've just tried to demonstrate some of these here, including radial search, which is a little different here. So we see this maximum distance. You can also have minimum distance versus k. If you remember in the previous searches, we had the k, so the number of results, the closest results that we wanted to return, we return the 9 closest neighbors or k nearest neighbors with radial search. Let's wrap this up. The last part of this is displaying our results. Remember I talked about keyframes, so there was a preview that was included when we extracted the information from 12Labs. There was a URL. Let me run this and then I will demonstrate where that came from. Just doing the same search results, we're actually using the search for our first semantic search. You can remember we got those videos back, but those really don't mean too much to us. Let me just make this a little smaller here. Probably just easier to see on the screen. So you can see we got 9 results back, but now at least I have a keyframe. So it returned them, and based on the description, the title, it was obvious that most of these were correct. But now I have a visual, so I have the name of the video, so I know, hey, that's the right video, this is where I go and get it. I have my score. You can change this. I just decided to show these fields. But if I look at these, yeah, these do look like 9 city street scenes, bustling city street scenes. There are cars, there are pedestrians, so it looks like our search worked. And ideally, if I viewed these, the one that scored the highest is going to be the closest to my description, and then second highest, third highest, etc. And then again, we could also look at the segment, and we could actually go directly to the segment within this video. Using these keyframes is useful. And again, that URL came from 12Labs that provided a URL, and ideally you'd want to download that keyframe and not depend on keep calling out to that location on 12Labs. I would probably pull that keyframe down or extract it with FFmpeg, and I would store that in S3 with a URL reference to S3. But again, we're calling that link directly that we put into our OpenSearch document. The other thing we can do is visualize our results in a 2-dimensional or a 3-dimensional space. So we talked about nearest neighbors, k nearest neighbors, or approximate nearest neighbors, k nearest neighbors. And when we say, closest neighbors, right, we have a dense vector embedding of our search query, then we have our search results, and how do those relate in a 2 or 3-dimensional space? So we can use a couple different methods. I'm using principal component analysis, and what we can do with that is, again, 1024 dimension dense vector embedding. We can't really visualize that, right? That's too many dimensions for us to visualize, but we can reduce that down to either 2 or 3 dimensions and then visualize those search results versus the search query using a 2-dimensional space or a 3-dimensional space. And we can do that using principal component analysis. There's other techniques, but we'll use PCA. I'm just going to run a search. We could have used a previous search. The only difference this search is I'm not excluding the vector embeddings. So when I run this query, I'm going to get back the search results. It's going to include the embedding because we want to take that embedding. We want to use PCA to reduce the dimensionality down to something that we can actually visualize in 2 or 3 dimensions. So I'm going to run that search. I got a search results back. I'm going to import PCA here. I'm going to run that. I've created a list of those embeddings. I've also created a list of video names. We're going to display the video names in the chart, in the scatter plot. We're going to run these embeddings through PCA, and we're going to boost the dimensionality of those, and that'll make a little more sense after I run this. So I ran that. So obviously we had 10, right? So we had 9 results plus the search query, that's 10. And we know that they were 1024 dimensions, so the shape would have been 10 by 1024. We've used PCA to reduce that down, so I still have 10 embeddings, but now there's only 2 dimensions. So it's reduced it down in a way that's hopefully maintained the relationship, that distance, that nearest neighbor relationship, but it's reduced it down to 2 dimensions, and now I can plot it in a 2-dimensional scatter plot. Number of ways to plot that, tons of libraries on the internet. I like Plotly, I use Plotly. You can use your own preferred method. So I'm going to plot that. I now have this list of objects which include the embedding, and I also have a list of video names. I'm going to go ahead and plot all that so you can read through this code. I won't go through this code in great detail, but you can see here that we visualize that. Now I can change the shape. There's ways to change the shape. This is just auto size if you want it more square, but you can see here's all our search results. Here are all the search results in their relative distance to each other, right? They're all neighbors, k nearest neighbors. And based on those embeddings and that reduced dimensionality, this is how we can visualize those in a two-dimensional space. And then we see we have our user query here. Now, you might expect this user query to be much closer, and so would I. I wouldn't get too hung up on this distance because it's all relative. Look at the scale here. We're talking about a relatively small scale. Although this description was fairly specific, I would have expected the scores to be a little higher, and I would have expected this user query to be a little closer. But again, it's relative. We got the search results back we wanted. The ordering was right, so I wouldn't get too hung up on the visualization. Just kind of visualizing. It's interesting to take a look at this using Plotly. Again, the same process, and as you can imagine with 3D, we're going to now have a shape which is 10 embeddings, right? The user query plus the 9 results. Now we have 3 dimensions, and this will allow us to use a 3D scatter plot. Plotly has a 3D scatter plot. You can visualize that. Let me just move that up here so we can see that, and then we can turn that around in space. And we can kind of see the distance here. So we see that same distance that we saw in the 2-dimensional plot, but we see the relationship in 3 dimensions. So we just get a little bit better idea of where they land in space. You can see the relative position of each of these to each other, and then the distance to that represents the user query, the black square, and then these dots represent the 9 results. You can turn these on or off. And the reason I'm doing all this visualization is, imagine you want to create a UI. So TwelveLabs has done a great job. Their index, their search, and their embed, they have a really nice user interface. You're able to visualize the videos in space. You roll over these, you get a nice preview, the different segments. They've done a really nice job building a really nice UI. That's really the advantage of TwelveLabs. If you're building this all yourself and you're using OpenSearch, you need to build your own UI, right? You need to have your own application on top of all this code that's going to visualize these search results to your end users. These are just showing some ways you could start thinking about that, right? Some of the different tools and packages you could use. Again, these are very primitive examples, but you start getting the example of how do I not only list my search results, but how do I visualize those, whether those are visuals of the keyframes or the segments, or how do I visualize those in a 2 or 3 dimensional space, depending on what your use case is. Plotly also has some animation. So I wrote a method here that just kind of animates and found some examples on the internet, modified those for these search results, and you can just play that. Again, depending on what your UI is, how you want to show these results. But that's about it. That is the blog post, and that's all the code for the blog post. I hope you learned a lot. Thank you very much for listening to the end.